I usually try to cut off at 10 just to make sure I don't forget. All right. Any ideas? What are those forces called? Remember, it was force in when we were going straight. But what happened? We called them something else when we started going around. Angle is involved, but
the torque.
Torques, right. If the sum of the torques, if the sum of the torques in a system equals 0 or equals 0, then what kind of momentum? Angular, that's a good one. Does not change. That was the same word from the last time. So there's your new law, now that we're going in a circle. Not much new to write home about, sorry. All right, so let's talk about, anyone have a cat that they own? You have just one person and all these people? Wow.
We're all dog people.
I've had cats. And I love cats.
All right. Don't have one right now?
No.
Okay. Here's what happens. It's a instinct. This law is instinctly embedded in the brain of your cat. So draw Molly's cat.
Molly's cat is really funny and really cute.
I know, right?
All right. Draw him like I'm drawing him. Or her.
What are you doing?
Oh, I get it. It's upside down.
Thank you. All right.
I don't
It needs other legs. Miss Powell.
Oh yeah, that's right. Thank you. All right. So draw a cat that has fallen, and he is completely disoriented. He's upside down. And instinctively, does anyone know what a falling cat will do?
They flip over to the
Yeah, but there's something they do to flip over, and that is they're going to go, some part of their body is going to go in a circle. What is it? The tail. As soon as they sense they're falling, it is instinctively in their brain, the law of conservation of angular momentum, so they start spinning this tail. So let's look at that mathematically. We say MVR before equals MVR after. All right. So before he even falls, he has no momentum. But when he starts to fall, the tail's not moving at all for an instant. So in the instant before, there's no angular momentum. But then he starts to spin his tail. So when he spins his tail, his mass doesn't change. He can't change the radius of his tail. It's as long as it is. So the velocity starts moving. So he starts moving. Let's say he moves at a positive 3 meters per second. I don't know how fast the cat's tail. So this says 3 equals 0, though. So something has to come out and start spinning in the other direction so that these are equal. So what will start spinning in the other direction in order to make up for the 3 in the positive direction? His body, right? So when he does his tail this way, his body will go that way, and so that's how he flips over. Actually, any animal with a tail should be able to do that, but it seems like the cat has it more in their brain than the other animals. Yeah, it's instinctive.
Could you look up the YouTube video of cat falling? I think they have
Like
some
in
so
slow
you can
motion?
see it.
Yeah, we'll do that on Monday. I need to start doing videos to start this class because we're done vanilla. Yay. All right, so the only other case I want to cover is the skater. Here's the girl with the short skirt. We'll make it longer this time. There we go.
Her parents wouldn't let her leave the house.
Oh, there's that. All right.
Because of her falling into that guy.
All right. The skater is.
I thought it was a guy in a skirt.
Sorry, I guess I
It's a
need a
Scottish guy.
ponytail back here or something.
Kilt.
Oh gosh. So anyway, here we have the girl skating,
Is that in
and she is in the middle of a twirl. So she's going around like that. So MVR before equals MVR after. This time, her mass is going to be the same, we're going to see what happens to the velocity, and her radius is the length of her arm. So she wants to, so this is a certain number, say it's a 2 meters per second. Velocity we'll say is, radius we'll say is, how long is an arm? 1 meter? We'll say 1 meter.
Oh, it's not that
The
long.
velocity is 2 meters per second, and I don't know what her mass is, but it's going to be the same on both sides, so I'll ignore the mass. How can she use this law to make her velocity, her spin, quicker? Well, these numbers have to be equal.
The radius has to be smaller.
Right, so if she wants velocity to go up, from these numbers to be the same, r would have to go down. So what does she do? She pulls in her hands, and she just automatically, because of this law, spins a whole lot faster. All right, that's all I want to say. Yep. Sorry we didn't get to finish pink. Work on it this weekend. And if you still need help when we come in Monday, I will help you do pink. I'll give everyone else something else to do. So give it your best. If you have it, I'll take it.